We as a group are here to represent our Capstone project, group number 68. The topic for the Capstone project is FPGA based reconfigurable soil health monitoring system. We are all students of electronics and communication. I am Sehjan. And I am Anisha.
I'm Aman. I'm Smarth.
And I am Eshan.
Now moving forward with our FPGA based reconfigurable soil health monitoring system. Broadly speaking, we have used three major components. One is basis 3 FPGA board, second is PMOD high growth sensor, and the third is a protocol on which our PMOD high growth sensor is operating on, that is I2C protocol. In our basis 3 FPGA board, as shown in the diagram, we are having the second pin as PMOD ports, the third pin as analog signal PMOD port, also known as XADC. The 4-digit 7-segment display is being shown by callout number 4, and the callout number 5 shows the slide switches, also present with LEDs and push buttons with callout number 6 and 7 respectively. Further, we are having P-mode high growth sensor, which we have used in our Capstone project. The P-mode high growth sensor is basically a relative humidity sensor, which is integrated with a temperature sensor also. It is having a high 14 bits of resolution, which is helpful in determining the relative humidity of the environment. PMOD Hygro is also designed to digitally report the relative humidity and ambient temperature upon the request by host port. Also, we have used in our project the I2C protocol on which our PMOD Hygro sensor is operating on. The I2C protocol is basically having a master and a slave. The SDA to SDA interconnection is present between master and slave, and SCL master is directing to slave SCL. The I2C protocol combines SPI and UART protocols for optimum and best performance. Also, the I2C protocol is very helpful for connecting multiple slaves to a single master like SPI, and we can have multiple masters controlling the single or multiple slaves, vice versa. However, in our present project, we have been using I2C protocol for our PMOD hygro sensor, but we can also use SPI or UART or different protocols for PMOD hygro sensors.
Coming to a hardware implementation part, we have used a Basis 3 board and we have connected this by a USB port to a laptop. We have used two different sensors like PMOD hygro sensor, which is connected to a PMOD JA port, and soil moisture sensor, which is connected to JB port. And we've also used a relay module, which will ensure that there is no sparking in between these sensors and FPGA board, and it will also ensure regulation of different power specifications.
So now coming to the hardware implementation part, we have made a Verilog code that is being implemented and run on Vivado software, and this is our Verilog code. We can see that we have used microblaze technologies which includes different peripherals, clocking units, and interface structures. So this is the Verilog code that is being used and implemented on the Basis 3 FPGA board. Now we'll go to the simulation part and run the behavioral simulation. So this is the final output waveform that we have got after behavioral simulation of the Verilog code. After that, we'll implement the code by clicking on the run synthesis and run implementation and generate a bit stream which we will put into the Basis 3 FPGA board to display the data of relative humidity and temperature of the soil sample. So we have successfully generated the bit stream and implemented the Verilog code, and this green light indicates that code have been uploaded on the Basis 3 FPGA board. So here's our whole hardware, and now we will display the relative temperature and humidity data on putty terminal, and we'll be selecting the COM5 port for our Basis 3. So opening it. So here's the display of the required output relative humidity and temperature data of this soil sample. Thank you.